Okay, class, so today we're going to talk about linear relationships in the form y equals mx plus b. Okay, before we start, we're going to define what each of these variables represent. So the y in the mx plus y equals mx plus b is going to be the dependent variable. So that's going to be my dependent variable. Okay, my m is going to be my coefficient, which we know that means the number before the variable, or the rate, or it is the slope of the line, which is the steepness of the line. Okay, our x is our independent variable. And our b is our y-intercept, which is where our line crosses the y-axis. And I'm going to put that here. Where line crosses the y-axis. Okay? All right. So now, a linear relationship. What is a linear relationship? A linear relationship means as one quantity changes by a constant amount, the other quantity also changes by a constant amount. Okay, now we're going to talk about representing linear relationships using a table. Okay, so let's read our example here. The length in feet of a humpback whale calf was found to be approximately 1.5 times, and I'm going to highlight times, his age in months plus 12. So we're going to use a table to represent the relationship between the length and the age. Okay, so the first thing we need to recognize is our independent and dependent variable. Okay, so x is going to be my independent variable, okay, and the y is my dependent. So age is my independent and length is my dependent. Okay, all right. So now let's talk about what this times mean. So 1.5 times his age in months plus 12. Okay, so now we're going to create our table here. We're going to create our x and y table. And if you remember, we did this when we did sequences last year. Okay, so we have x here and y here. Okay, and so we're going to write this out. 1.5, okay, times his age plus 12. Okay, so now our x values will go along this side of our table. So 1, 2, 3, 4. Okay, and as we know in here, that's our rule. Okay, this is the input, this is the output. So we're going to put our rule here, which is 1.5 x plus 12. Okay, so wherever we see the x here, we're going to input that x value. Okay, so 1.5 times 1 plus 12 would give me 13.5. Okay, 1.5, and I'm going to put that 2 there because that's my next x value, plus 12 would give me 15. Okay? So now what I want you to do is, I want you to complete this part right here for class tomorrow. Okay? And also input your values where they go. So we're going to do our first value here, which is 13.5. Okay, so, and then this one would be 15. Okay. All right, and then when we're done, this is actually our equation in the form y equals mx. So this would be our slope here, or our steepness of our line. And this would be our y-intercept, which is our b. Okay, so have those two done for class tomorrow. Okay, all right, so now we're going to do representing linear relationships using a verbal description. All right, so now the Ecology Club is holding a car wash to raise money. The club received a pledge from its parent group. Now the table shows the relationship between the number of cars washed, so number of cars washed, and the amount the parent group pledged. So we're going to use this table to give a verbal description, meaning we're going to actually write out, okay, between cars washed and amount pledged. Okay, so our first step, let us recognize or determine which one is our independent and our dependent variable. Okay, so here, the amount of money depends on how many cars that you wash. Okay, so amount pledged will be my y, or my dependent variable, and the amount in the cars would be my independent variable. Okay, our second step, we're going to figure out how do we get from one to the other, which is called our common difference. Okay, and we do that by doing our change in y divided by our change in x. And if you remember back in module 2, we did what we call was the k value, which is also called the slope or the rate of change. Okay, so this is our y value, so we need to figure out common difference from here to here, here to here, here to here, here to here, and our change in x. Okay, so our change in x is pretty easy to see because we get from 1 to 2, this is just 1, just going up by ones. Okay, so now if I want to actually do this, I would have to do 84 minus 79.5, and I would get actually 4.5. So 4.5 is my change in y, if I were to subtract all those numbers. Okay, and my change in x, what you said was 1. So actually my slope or my rate of change would be 4.5. Okay, so I know I can go ahead and write y equals 4.5 x. Okay, so now my next step, okay, would be to do my table. Okay, because now I got to find out what my b value is. So I'm going to do my table here. Okay, I'm going to write my x values. Okay, and I have part of my rule, but I got to figure out, and I'm going to write my y values here. 79.5 when it's 1. 2 cars is 84. 3 cars is 88.5. 4 cars is 93. And 5 is 97.50 cents. Okay, so now I have to figure out, when I go through here and do 4.5, remember every time I see the x, I'm going to put my x value times 1. So when I do 4.5 times 1, I get 4.5. So how am I going to get from 4.5 to 79.50? Okay, so I know if I add 75, I would get 79 $1.50. Okay, so to figure out that's my actual y-intercept, I need to go through here and see if that will work. I want you to do that part. I want you to finish this part here and write the other part of this here. Okay, and I want you to give me a sentence that would give me the relationship between the cars washed and the amount pledged. Okay, I want you to have that completed and the rest of this equation here for class tomorrow. Okay.